So the first thing we're going to do, we're going to install Ember CLI Fastboot. And for those who don't remember from the last course, Ember install is just some nice layer on top of npm install that runs some post-installation code and gets add-ons set up properly. So all that happened here was apparently some reformatting of my package JSON, but there's Fastboot right there. So the way we start the app up is Ember Fastboot serve assets. This is going to fail because, or it will, I don't know if it will crash at build time or when we run it, but it's building the app now. OK, so what's happened is we have a Fastboot version of the app built, and we have a couple listeners spun up. So this Fastboot server will actually, based on how many cores you have on your computer, it'll spawn child processes to listen for requests, right, for however many cores. So if we try to access our app at localhost 3000, we will see an error. And if we blow this up a little bit, navigator is not defined. So this is because we've tried to use a global that is not available in our server-side rendering sandbox. So we're going to add a guard around this portion of our initializer so that it only runs when we're launching the app on the client. So I'm going to kill this here. And I'm going to open up app initializers geo. And there's our code here. So I'm just going to, our client-side guard, remember, is checking for the presence of a Fastboot global. So if it's undefined, that means we're in browser land. Only if it's undefined do we want this to be run. And some of you may have gotten an error message about dist/node modules not being able to clear that. We're fixing this simply by putting the Fastboot build in a folder other than dist. It's a simple fix, but for now, you can just blow that dist node modules folder away in between launching Fastboot. All right, so serve assets. And there's our Fastboot build completed. And you can see, doesn't this look familiar to the way your app starts in the browser? Sometimes in the console you see this. Not a coincidence. The app just started up on the server. It's the same console.log. And if we refresh, everything should work nicely. So if we look at, if we view the source here, we can see that what came over the wire here, here's some real content, right? This is fully populated already. If we compare this to what was deployed on Heroku and view source here, well, whenever that gets around to coming back, it's going to be the empty index.html you're used to seeing. There it is. So there's really no content here. This is the blank page, whereas this here is the body starting here. We can see that this is the rendered app, and we can even see that here we have no latitude and longitude on the server. So when it's rendered, these values are undefined, right? So if we refresh our app, I want you to pay attention to how this works. I'm going to revoke my permission to use notifications here, to get location, and refresh. So you can see that the app, the experience has landed, right? The CSS is in place. The index.html has some stuff in it. Lat and long clearly don't have values here. So the state we're in now is the app hasn't really booted yet, but the experience looks pretty good, right? And if we allow, we can see that it's going to take its sweet time, figure where I am, and then we should see the data refresh. And in fact, we do. There's my latitude and longitude. So we have a server-side rendered app now, and this is your starting point for adding, the structured data to your head tag, and for starting to, make that rendering experience a lot nicer for your users. I will compare these two, although it's not really fair to compare a locally rendered page with something that's hosted on Heroku, but just so you have some point of comparison here. So if we look at the timeline, the point at which, sorry, size is screwing me up here. So we can see that things were taking up to like 7 and beyond 7 seconds to finally get that JavaScript to land, and then to make the AJAX request to our API for that data to come back. It took quite a while for this to start up and to fully settle. If you compare that to, what's happening with server-side rendering, and turn the timeline on, really we're talking about, well under 2 seconds here. And if you look at some of the things that happened after the 2 second mark, this is new API requests going out when the client-side portion of the app has started up, right? So the data is already on the screen. We already know that this is baked into the HTML, the titles of all of these different posts. So we're refetching that data on the client as basically a completely new app starts up and sort of takes over the job of managing everything in the browser. So the real startup time is much sooner than that, probably around this time here, where we're talking about like less than the 700 millisecond mark. So this is plenty fast. Obviously, there's not much here to download. It's a very small app, but this is the main thing that you're aiming for, and the reason that you should be excited about Fastboot. So we served the assets. We compared client-side rendering and server-side rendering. We're going to leave this in place and build on top of it and move forward.
Couple questions. Do you want to cover them?
Question, yes, absolutely.
The last one that just came out. Is there a list of incompatible or compatible Fastboot add-ons?
So I don't believe that there is a list, but many of the most popular add-ons are Fastboot compatible. And when Fastboot first was made available as a beta version, about 7 or 8 months ago, a bunch of us went around and kind of played whack-a-mole and upgraded, several hundred of the most popular Ember add-ons. Personally, for my add-ons, and I've got probably 30 or more of them now, I do put Fastboot compatible right at the top, so it's easy to see. I don't think I have any incompatible ones, because you have to think that like once their app is running in Fastboot, everything they bring in has to be Fastboot compatible. So there's a lot of motivation to like be able to contribute to open source and fix some problems that are out there, just because oftentimes it's a new guard that needs to be put into place. It's nothing huge, but this is an easy thing for people to go around fix in their own interest so that they can use the code in their own app. So if I had to guess, I'd say above 90% of actively maintained add-ons are Fastboot compatible. And it obviously is only growing.
And then a question that came up earlier was there seems to be a lot of complexity around the app architecture of adding like Fastboot or the server-side rendering. Can you talk about how companies decide on taking on that complexity versus serving it up the old-fashioned way?
Sure. So server-side rendering is inherently a little bit complex. You're running essentially a headless browser or something akin to it on a node server somewhere and trying to make it run fast. You don't want to make the problem worse by taking a few seconds to render on the server and then a few more seconds to render on the client. So I would argue that some of this complexity is unavoidable. The general idea is you kind of set fastboot up, and then you can develop as usual. Once you install new add-ons, like the reason we're hitting these hurdles right now is because this is the typical experience of setting a major app up so that it works in fastboot. And you'll note that we're going to get there, like we are there, and it's only half a day that's passed. But if you look at Angular 2's server-side rendering technology or React's, there is nothing that is quite, nothing that can be just dropped in and it just works like magic in a performant and maintainable way. There is some finesse that's required to perform this task, no matter which path you choose with which technology you're using. We did figure out, someone in the room figured out what was going wrong with that fingerprinting issue, or when we deployed to Heroku, things were, we got an error related to integrity. And the reason is that there is, by default in Ember apps, something that will it'll essentially fingerprint your JavaScript and your CSS files during the build process. And it will add those fingerprints to the script and the link tags themselves, right in your index.html. And that instructs the browser to abstain from loading that code if it receives something, if it downloads the resource in that script or link tag and it receives it, and that fingerprint, it doesn't match the asset that it received. So we screwed that up by adding the comment to the top of our JavaScript files, adding our little broccoli plugin. We essentially fingerprinted it and then tampered with it and then witnessed the browser doing exactly what it's supposed to do. And it said, I didn't expect any comments with emoticons at the top of my JavaScript. And so for security, it essentially assumed that someone had messed with it maliciously and put on the brakes and stopped us from moving forward. So not a common thing to run into because you don't commonly write that kind of broccoli plugin. The way you would fix it is you'd make sure that you write the comments before the fingerprinting process happens. So you would not want to, with the finalized app tree, go and write that out. You would want to basically insert that broccoli plugin earlier in the process so that it gets fingerprinted afterwards.